So here what, uh, for example, if I am plotting my points like something like this, x versus y, okay, and my data is like this. Okay. So what is the work of your linear regression is to find out a straight line such a way that it discriminates, or it creates a decision boundary between the two data points, okay, so that this data points can be grouped under class 1 and this could be grouped under class 2. Okay, so this is the work of your linear regression model. For that we use the formula y is equal to mx plus c. Few cases it can be written also as b naught b1x plus b naught. So just like your logistic regression algorithm, the work of this linear regression model building is to, 1 second guys, okay, just a minute. Okay, so the work of this linear regression model is to find out this b1 and b2, sorry, b naught. Okay, so x can be your feature attributes. It can be x1, x2, x3, like that, up to x. So once you identify this b1 and b2, so I know y also here. So y is the target classes for the corresponding feature attributes, y1, y2, like that it will be. Okay. So when I find out the b1 and b0 with the help of my linear regression algorithm, when a new test data comes, I will use this existing b1 and b0, okay, on my new test data and find out the class of my test data, that is y test will be formed. Okay, so normally we call this as y predict. Okay, so this is a very simple linear regression problem. You have several high-end models also, depending upon the slope or the curvature of your what to say, the degree of the polynomial of this equation. It can be changed to quadratic equations also. Okay, so coming back to the implementation. So again, so this linear model can be directly taken from the sklearn's linear model library or a linear model submodule. Okay, so I'm going to take a data set called as diapetus data set. Okay, so in the diapetus data set, I'm just trying to take my testing and training data. Okay, so I'm directly doing a manual splitting over here. Okay, so trying to take only the first 20 data for training, and like that I'm trying to split. Okay, so and this can be you're calling your linear regression model and trying to fit it and predict it. Okay, so here what we are trying to do is we are trying to take the zeroth value of your x test alone and putting it in the x naught, x, a variable called as x naught. Similarly, only one feature I am going to take and take it as my training data and my testing data. Not all features I'm going to take, only one feature I'm going to take and take it. Okay, so we will try to see how the data points. The reason why I am taking only one feature is to see how it can be mapped. See, so for the first feature alone, so this is how the slope, the line equation is created. So this is a set of data point and this is a set of data point, and the line equation is created like this. With the help of this linear regression algorithm, the B naught and B1 is calculated, and it's been created like this. Okay. So this is a score of your